Hey guys, welcome to this latest lesson about radicals. It's multiplying and dividing. This one you guys are going to be okay with because the rules work the way you like them to work. But I would say there's a couple ways of thinking about this. It just basically means that there's not just one way to do these problems. You may know that the square root of 4 is 2, and the square root of 25 is 5. So this lose 2 times 5, which is 10. So you can kind of do this, the radicalizing first, and then multiply after, or you can multiply first. You can write this the square root of 4 times 25, which is the square root of 100, which is also 10. So like this kind of works either way. You get the same answer and both are correct. So you're like, which one is correct? And the answer is they both work. There's really no, as far as the square root and the multiplying, it doesn't matter the order you do them. That's what I'm saying. And the same is true for other roots, like a cube root, for example. Cube root of 27 is 3, and a cube root of 8 is 2. So there should be 6. And this should work the same if I multiply the numbers underneath the radicals first. 27 times 8 is 216. The cube root of 216 is 6. The 6 times 6 times 6 is 216. So this works both ways here. Multiplying first, like this is technically multiplying first, then cube rooting, or cube rooting first and then multiplying. So that gives us what I call the product rules, which tells you that the nth root of A times the nth root of B equals the nth root of A times B. And because this is an equal sign, it kind of goes both directions, which is why this works either way. It doesn't matter. The important thing to remember here is that the radical expressions, the radicals, must have the same index. What that means is that it's really important that if this is n, then this is n, and this is going to be n. But like if these aren't the same, you can't do this. And that's why we had 2 3s here, 2 3s here works, and there's really 2s here. We don't write them, but there are technically 2s there. And if those weren't both 2s, then you couldn't do this. So as a product rule, we use this to simplify radicals all the time. Square root of 20 is the square root of 4 times 5, which is the square root of 4 times the square root of 5. I probably said this to you before, like just done this from here to here without saying that that's technically like an official rule of radicals, but it is. Like this, the reason I can split this thing up like this and then take the square root of 4 is because of this rule. Which, like I said, up until now, we never really said this is officially a rule. I just did it, and you guys were like, okay, I guess that's a rule. But that is how this rule works, the product rule. So we can do the same thing for these other ones. There's probably more than one way to think about how to break up the square root of 200. You can like use the factor tree method, which is probably something you guys will do a lot. I noticed on your tests that I graded for the square root of 75, a lot of you did the factor tree, which is fine. In my mind, it takes a little longer, but it always works. So given those two things, I'm kind of okay with you guys doing it. I look at the number 200 and I'm like, what's the biggest number that's a factor of 200, which is a perfect square? The answer is 100. 200 is 100 times 2. Again, this is the square root of 100. Oh, maybe that's the 1. Times the square root of 2. The square root of 100 is 10. So this is 10 times the square root of 2. And that's that. So you all might break it down like 2 of 100 and then 2 of 50 and so on and so forth, but I just like to do it like this. So we can do it with these bigger, more unattractive radical expressions where there's like a whole bunch of stuff in here. So we can maybe think about breaking it up into pieces and then putting it back together. It might be helpful for you guys. I don't know if you'll find this helpful or not. You can think about this as root 216 times root x squared times root y squared times the square root of z. I just split up all the numbers, the x's, the y's, and the z's. And I know that I got to leave that -4 there. 216 is 36 times 6. The square root of x squared is x. Like there's two x's in here, so they come out to the front as just an x. The square root of y squared is just y, and I can't simplify the square root of z. There's only one factor of anything in here, which is z. So the square root of 36 is 6. So that'd be negative 4 times 6. I'm going to move the x and the y to the front also. And I got root 6 and root z, which is negative 24xy times square root of 6z. So you can see I combined the numbers. Negative 4 and 6 became negative 24. The x and the y are just multiplied. I can't multiply them together. I don't know what either of them are. And the root 6 and the root z, this isn't meant about putting it back together. Like I separated all the radicals first, and then I'm like, all right, let's put them back together. Because now I know what stays under the radical. As in, like, what part of this big expression was not a perfect square? Just a 6 and a z. Everything else is part of a perfect square. It's not the only way to do this. It's not actually the way I would do it normally, but I think it is. It's descriptive. It shows you what's happening. Demonstrative. I don't know if that's the right word. So I think that is a good indicator of why these things come out if you do it this way. So let's do these cube roots. These are a little trickier because you got to look for perfect cubes, which you guys aren't as familiar with. So basically, if you do the factor tree now, you have to circle things 3 times instead of 2 times. I could say over here, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. You've actually seen this one twice today already. But these are like anything bigger than this. I mean, you could memorize them, but 7 cubed is 343. 8 cubed is 512, but like at some point it becomes kind of diminishing returns to memorize these powers of 3, or these these third powers. So basically I look for one of these numbers that's a factor of 72, and I can tell you right now that it's 8. And I think it's better, and there's no reason to think this, to factor out the negative one. With cube roots, you can factor out a negative number, because the cube root of negative 8 is negative 2. And like, it might feel a little weird at first to be like, I know I could take a 9 out, but you can't if it's only, you can only take a 9 out if it's a square root. Cube root of 9 is some number that I don't know, somewhere between 2 and 3, probably pretty close to 2. But it's like it's not a whole number. It's definitely not 2, or sorry, it's definitely not 3. Square root of 9 is 3, and cube root of 9 is not 3. And just to make the point here about how I went from the cube root of negative 8 to negative 2, think about what negative 2 cubed is equal to. It's negative 2 times negative 2 times negative 2. And that's 2 times 2 times 2 is 8, but there's a negative, and a negative. So it's like negative times negative makes positive, then times a little more negative makes it negative again. So the answer is negative 8. So this tells me specifically that the cube root of negative 8 is negative 2. Because I know that what's the number I cube to get negative 8? Negative 2. Okay, we can do this one also. Again, if you make a factor tree here, you got to look for something that appears 4 times. So this is not so obvious, maybe at first. I happen to know off the top of my head that 3 to the 4th is 81. And 162 is 2 times 81. The 4th root of 81 times 2. See, I can take out, there's 4 x's in here, I can take out as 1x. That leaves behind 2x squared. So we want to think about what the 4th root of x to the 6th actually represents, how many x's there are in here, and realize that I can take out 4 of them, because that's a 4. The 4th root of 81, if 3 to the 4th is 81, then the 4th root of 81 must be 3. And there's an x. The things that are left in the radical are 2x squared. So So that's how you simplify this guy. That's the product rule. I say we take, I'm gonna break this here and we'll